All right, we are on number 10. The function is, this is section 13.3, concavity, y equals x cubed minus 6x squared plus 9x plus 1. So we'll take the first derivative, which is going to be 3x squared minus 12x plus 9. And then we'll take the second derivative, which is going to be 6x minus 12. Setting that equal to 0, we find out that the candidates for inflection points are x equals 6. No, x equals 2, sorry. So let's set up our sign chart. We have 2 as a potential candidate for an inflection point. Then we have the interval from 2 to infinity, and we have the interval from negative infinity to 2. We want to evaluate the second derivative at 6x minus 12, and that'll tell us the sign for the second derivative, and thus establish the nature of the function, whether concave up or concave down. So let's start with 0. 0 is between negative infinity and 2. That gives us a negative there. That means the second derivative is negative. So that means the function is concave down. And by the way, I've mentioned this in class, and it's something you should probably think about if you're going to go further in economics. In economics, when we characterize something as concave down, we just call it concave. And if it's concave up, then we call it convex. So I remember when I started economics, everybody was like concave and convex, and I was like, what are they talking about? Like, is there some mathematical property I'm not aware of? And then it turned out that we're just talking about concave up and concave down. So this, like many things in economics, like usually economists have their own sort of terminology for things, and it can sort of muddy the waters of understanding the concepts, because you think that you're just completely, incapable of like speaking the language initially, but the truth is that you already speak the language, it's just used different words. A little aside that you probably didn't need, but I thought I'd throw out there. I'm sure I mentioned it in class as well. Alright, let's look at the last interval from 2 to infinity. Let's plug in 3. 3 times 9 is negative. 3 times 6 is 18 minus 12. That's positive. So f double prime of x will be positive from 2 to infinity, and so the function will be concave up. And thus 2 is a point of inflection. Again, that means that as the function passes through point 2, x equals 2, it shifts from being concave down to concave up. And we are done with problem 10.